Hello, everyone. Thank you for joining us, and I'm very happy to welcome our speaker today. He's really fantastic, Dr. Chris Mack. He's coming to us from the University of Texas at Austin, and he's an associate professor there who is also the editor-in-chief of the Journal of Micro and Nanolithography. So I think he's going to have a really fantastic talk for us today, all about how to get published and how to write a good science paper, even if you feel you aren't the strongest writer. I think he's got a lot of good things to say. So please feel free to type your questions into the chat box, and Dr. Mack will answer them at the end of the presentation. Thank you.
Thank you very much, Amy. Pleasure to be here today and to speak with all of you online in this webinar. The subject of getting published is generally a subject of interest to most working scientists and engineers, since publishing is often an important part of your career, and it's an important part of science as a whole. The big subject, how to write a good scientific paper, how to get that work published. I won't be able to cover nearly all the interesting topics that I'd like to talk about, but I would like to focus on one aspect of getting published, which is making sure your paper is written well. But before we get started, let's talk about what science really is and how publishing fits into the overall scientific enterprise. I think of science as having three important parts, kind of like the three legs holding up a stool. First is a communal collection of knowledge. These are facts, data, and theories that we've collected over time to describe what we know about the world. Next thing is a method for evaluating this knowledge. In particular, a method for evaluating whether our scientific theories are any good by comparing the predictions of those theories to our observations or the outputs of our experiment. And finally, the third important aspect of science is an attitude of skeptical inquiry. We have to have the attitude that all of our knowledge is provisional, tentative, that we will revise our theories, revise our beliefs based on new evidence. All three of these things are required in order for science to work and for scientific progress to continue. One of these things is where publishing has its biggest impact, which is the collection of communal knowledge. Scientific journals serve this purpose, among other avenues, for creating this collection of knowledge. You have to have mechanisms for preserving and disseminating this knowledge. For those of you in our audience who are students, you probably are very well aware of one of the most important ways in which we preserve and disseminate knowledge, and that's through education. Universities, textbooks, classes, professors taking their knowledge and spreading it to the next generation of scientists. There's also scientific presentations at conferences. There's communities of scientists that get together and discuss. But by far the premier way in which new scientific results are propagated throughout the scientific community is the peer-reviewed scientific journal. All of these mechanisms are important, but the scientific journal has a special role to play. Here I show in the corner a picture of the cover of the world's first scientific journal, which last month celebrated its 350th anniversary, Philosophical Transactions of the Royal Society of London. In order to be a part of the scientific enterprise, to take new knowledge and add it to the communal collection of knowledge through the avenue of the scientific journal, you have to get that work past the editors and reviewers of that journal. So what do editors look for in a paper? That is something that to many people, especially new scientists, people who are just starting out in the field, just starting to get their work published, it can be maybe even a little mysterious. Exactly what it is makes one paper publishable in a specific journal, but not another. As the editor-in-chief of a journal for many years and someone who's published many papers over my career, I can see this process from both sides, the editor's side and the author's side. And so I'd like to explain to you in very basic terms, in simple terms, what it is an editor will look for. There are 4 criterion that a paper must meet in order to be published in a specific journal. If you miss out on any one of these, your paper is going to get rejected. What are those 4 things? First, scope. The content of your paper must match the scope of the journal. That's because the journal serves a specific audience, and you must have a paper that matches that audience. We'll talk about all 4 of these things in more detail in the slides to come. The second thing is that the quality of the paper must be sufficiently high. The quality means the quality of the research and the quality of the writing in which you communicate that research. The third thing, it must present novel results. Peer-reviewed scientific journals are in the business of presenting new information to add to the communal collection of knowledge. Now, there's review papers and tutorials that are an exception, but the regular paper must have something new. You could do fabulous work, but if it's already been done before, it will not get published in a peer-reviewed scientific journal. And finally, the fourth thing, results must be significant. In other words, they must attract readers that want to read these results. Let's go through each of these in a little bit more detail. Scope. Every scientific journal has a specific scope, a specific audience in mind. There are a couple of journals that are extremely broad-based, journals like Science and Nature, that pretty much cover, well, almost everything. Even those journals, however, don't quite cover everything, but maybe most aspects of science. Outside of those very broad-based journals, every journal has a specific niche that they're trying to fill. American Journal of Chemistry. Well, it's about chemistry. You're not going to be able to publish a math paper in that journal. I'm in a journal that has a very niche in the world of nanotechnology, microfabrication. Nanofabrication is the area of my journal. And if you write a fabulous paper that's groundbreaking, important work, but is not in the area of nanotechnology, fabrication, I'm going to reject your paper. So if you want to make sure that you don't get rejected on this very simple criterion, research the scope of the journal you're interested in carefully. Pick the journal with the best match to the scope. In other words, you want to find the right audience for your paper. You want to get the right people to read your paper, and those people read the journal that is the best scope match to your work. Now, many of us think what we should be trying to do is get published in the journal with the highest impact factor. I'm not going to go into the whole debate about the value of impact factor as a way of judging journal quality or paper quality or anything else. But I'll just say this. If you use impact factor as your sole criterion for deciding which journal to publish in, you're making a big mistake. What you want to do is to get the right audience. In my opinion, you find the journal with the best scope match. Then, if there is more than one journal, because there often is, you might use prestige or the impact factor as a deciding factor between them. Once you've picked the right journal to submit to, the next question to ask is, does your work have novel aspects? Is it contributing to this field of science? New theories, new methods, new materials, tools, data, analysis. Something has to be new, not been published before. How do you know if it's new? Well, you had better have done an effective literature search. Could go on for a while on how to do a good literature search, but I'm not going to have time to do that today. But if you don't do a good literature search, it's a reasonable chance, you're just rolling the dice, reasonable chance that there'll be some other work out there that's already done this work. You should, in your cover letter, explain what's new in the paper. Also, as I'll point out in a few minutes in the introduction. Once you've proven, demonstrated, that you've done something new in your work, excuse me, I skipped a slide, then you have to next show that these results are significant. What do I mean by significant? Well, it means you have to produce something that the readers want to read. In 2012, there were 28,000 peer-reviewed journals publishing. They published about 2 million articles. That is a massive sea of literature that none of us have even close to an opportunity to look at. One consequence of this is that most published papers are never cited. Many of them are probably rarely even read by anybody. You don't want this to happen. You want to make sure that you've written something that has some significance, that people want to read about. Most people use a couple of possible measures of significance. Citations, the number of citations over some time period is the most significant, but also the number of downloads is an important metric. Sometimes the number of social media mentions can be used. But significance is most important, not in general, but to the audience of the specific journal that you're submitting to. So it's how would that audience judge your significance, not the general population. And the fourth criterion is quality. Have you written up quality work? Now there's two aspects to that. One is the quality of the research itself. I am not going to talk about that today. Hopefully, if you're a student, you've got advisors that are helping you understand what it means to do quality research. If you're a researcher yourself, hopefully you're continuing to learn every single time you practice science and research, learning to do a better job, quality work. What I'd like to talk about is the second half of the quality equation, which is the quality of the writing. And here, the most important thing is don't give the editor or reviewers an excuse to reject your paper simply because the quality of writing is not very good. So that's what I'd like to spend the rest of the time of this seminar, this webinar, talking about, is how to ensure that you have sufficient quality in your writing that people can actually understand what it is you did and why it's important. Sometimes you can do really good work, but it gets hidden under a jumble of poorly organized and poorly written words so that nobody appreciates how valuable what you did really is. Now, I know writing is doesn't come naturally to many scientists. This is especially true for people in the research community for whom English is a second language. English has become, for better or worse, the default language of science, and if you're going to publish, chances are you're going to be publishing in the English language. I can't imagine how hard it would be to publish in a foreign language. I've never done it. I can't imagine doing it myself. I give my hats off to anybody who can write a paper and get it published in a language that's not their native language. That said, you still have the same standard that applies to you as to applies to everybody else in terms of the quality of the writing. And you have to bring it up to a level so that editors and reviewers can properly evaluate the work that you've done. The good thing is you don't have to be a good writer to write a good paper. There's a method. There's a formula to get a paper written that if you learn, you can do a much better job of putting your ideas onto paper, and it will make your writing job much, much easier. So I'd like to cover some of the basics of this formula of how to write well. I won't be able to cover in the time we have remaining all of these topics in any kind of detail whatsoever, but I have written a number of couple of page papers on each of these topics. The web address there at the bottom of the slide shows you where you can find these short papers on each topic, and I would recommend that you look at them when you're interested in that specific topic or working on that specific aspect of your paper. What I'm going to do now is review these topics very, very briefly and then just rely on your ability to go and look up more details after the fact as you need them. First is organization. You should organize your paper before you start writing words. The two goals of organization: effective communication, which is your goal of all aspects of the writing process. But there's a second goal as well called opportunistic reading. You know that people are searching for the right paper to read. Everyone wants to find the paper that tells them the thing that they want to know. How do they find it? Well, they're going to do some keyword searches. They're going to look through titles, briefly read an abstract. At each stage of this opportunistic reading, they'll decide whether or not they want to read any more. If you organize your paper well, people can quickly skim the abstract, some of the introduction, jump to the conclusions, look at a couple of figures, and within a few minutes decide if this paper is worth reading. So, how do we accomplish the goals of effective communication and allowing for opportunistic reading? The easy way is to use the standard structure called the IMRAD structure. It is introduction, followed by method, followed by results and discussion, followed by conclusions. My recommendation is to organize your paper in this way, at least to begin with. Then, if the story that your work is trying to tell would be better served by a different organization or a variation on this organization, by all means, change it. There's no rule that says you have to follow the structure. But this is the structure that scientists and engineers expect when they start to read a scientific paper. And I think you'd be best served by starting with this and then deviating only if that makes sense for your specific topic. Let's go through each of these points in more detail. First, the introduction. The introduction should have 3 parts, and let me tell you, there's a lot of badly written introductions out there in the publishing world. Often bad because they miss one or more of these 3 parts. The basic 3 parts are a topic, a problem, and a solution. That's kind of an engineering way of looking at the world. In science, we might call it a topic, some discovery or observation, followed by an explanation. Either way, it's the same 3 topics. Another way of describing it, you begin by establishing the territory within which your work is involved. What's the field of work? Why is this field important? What's already been done in this area? Then establish a niche, something that's missing, a gap. Raise research questions. Challenge some prior work that you think is wrong or missing something. Then explain how you're going to occupy that niche. What research questions are you going to be able to answer in this work? Those are the 3 things that should always be in an introduction. You should always make it clear to the reader what is new and why it is significant. Right there in the introduction. Sorry. Next comes the methods section. The methods section describes how results were generated. Results could be data, results could be a theory, results could be a new model or a new design. Lots of things that could be the results. Classically, it's some set of data that you've measured. The method section describes how those results were generated. Here's one of the biggest, most confusing areas of the method section. Nobody knows how detailed to be. You can't be completely detailed. That's what your PhD thesis is for. It's chapters and chapters of detail. You can't put that into a published paper. But many people put too few details in their methods section. The question you have to ask, have I given enough detail in my methods section that an independent researcher who already works in this field, already understands the basics of what this field is about, have you given them enough detail so that they can validate your conclusions? They don't have to be able to exactly reproduce your results. They have to reproduce some set of results that is equivalent to allow validation of the conclusions that you're going to make, that you're drawing from your results. If you haven't given them that much detail, then you haven't done a good enough job in the methods section. Next comes the results and discussion section. Usually, presentation of results is very quick. It requires some graphs, maybe a table, often a few sentences or a paragraph to say, here are the results. The key, the real meat of this section is the discussion. You need a discussion for the very simple reason that evidence does not explain itself. You cannot present a graph and expect that everybody will simply look at the graph and draw the same conclusions from that data as you did when you looked at it. That's not the way it works. You have to explain why the data supports conclusions, the answers to the research questions that you have posed in that introduction. Generally, the discussion flows the following way. You summarize the results, discuss whether these results were expected or unexpected. Both are perfectly good options. You compare these results to previous work, either your own or maybe something published by some other group. And then you interpret these results, explain them. You often compare them to a theory. You compare, like I said, to other people's work, and you try to interpret the meaning of these results. And the last thing, most important thing, hypothesize about the generality. If these results only apply to that one experiment you did, and they don't apply to any other experiment anyone else would ever do, well, how good is that? There has to be some amount of generality about the results you've done. So how general are they? This is one of the key things that you need to discuss. And finally, the conclusions. The conclusion section, to enable opportunistic reading, should be a standalone section. Should be reasonably readable on its own. If you only read the conclusion section, you'd know a lot just from that. What should you do? First, provide a very brief summary of the results in discussion. Do not repeat results in discussion. Just quickly summarize in a sentence or two, maybe a paragraph. Then you explain very clearly, directly, how each research question that you posed in the introduction has been addressed by your work. Once you've done that, you explain or emphasize implications of this. And again, emphasize the level of generality of the conclusions that you're allowed to draw. Explain why this is significant to the readers, and then optionally present a roadmap for future work. If you follow that organization, you'll have a paper that people can look at and properly evaluate how good your work is. And that is necessary in order to review the work and decide whether it's novel and significant and matches the scope of this journal and therefore should be published. If you cloud these sections up, everything's mixed up in terms of where, and people don't understand the significance or why it's important or how general it could be, you might end up with your paper rejected, even though the quality of the work was high. So organize well and write well to get these points across. There's a few more topics about writing a paper I'd like to mention as well. One is authorship. As the editor of a journal, I have dealt with problems related to authorship. Some people believe they deserve to be an author, and they were excluded. Other people are included as authors when they didn't even know that they were being included. What does it take to be an author? If you're writing a paper and you have to decide, of all the people in my research group or that I've collaborated with, who deserves authorship, well, I have a three-part test that you can make to see if a person belongs. The first and most important part is, has the person made a creative contribution to the work? Now, here's what I mean. A creative contribution is some intellectual contribution that enhances the novel aspects of the work. Now, if somebody did routine preparation, routine measurement, routine analysis, and has nothing to do with anything novel about what you've done, that might be very valuable. It might be even essential to the work. But if it's not a creative contribution to the novel aspects, then that person in that work belongs in the acknowledgments, not in the list of authors. Next, if you list all the people that have made a creative contribution to the novel aspects of the work, you need to make sure that those same people ask the next two tests. One is, has the person reviewed and approved the final manuscript prior to publication? Don't submit anything unless every single author has seen the paper that you're about to submit. And finally, does this person accept responsibilities that come with authorship? Being the author of a paper comes with responsibility. That responsibility is your willingness and ability to answer the paper, answer criticisms that might be leveled against it. Someone who's unwilling or able to answer for the work that's been done shouldn't be an author. Another very important part, a critical part of the paper is the list of citations. Remember that we're taking this work and we're adding it to the communal collection of knowledge that holds up science. In order for this paper to have an impact on your community, it must be placed in the proper position within the framework, within the body of work that's already been done. Citations help to do that. The mechanism for the citation is the reference, a reference to a source of information or data. Every journal has a specific format. But what you need to do is figure out what prior artwork should be cited in this work. A good citation practice thus begins with a good literature search. Unfortunately, some people do this at the end. They write the paper. When they're done, they realize they don't have any citations, so they add one or two, maybe to their own work. And they quickly do a literature search and throw in some last-minute citations. That usually results in problems. In order to decide whether a citation belongs, you have to see whether this citation meets one of the 5 goals of citations. Now, in the interest of time, I'm going to skip through this. Just mention that there's more than one goal. This last goal here, acknowledge and give credit, is usually what most people think of as what citations are all about. But that's really only one of the 5 goals. Please review this list at some other time when you're working up your citations to make sure you understand why something should be in your list of references. Some of the problems that we often see in the publishing world with citations are something like this. Spurious citations, that is, including citations that are not needed. You need 20 citations to make it look good, so you just throw in a bunch that are on the same topic, sort of. Don't do that. Here's the question you want to ask. If someone were to look up that citation, you've cited it in your paper, they go look it up, they download the paper, and they read it. Will that have been time well spent for the reader that's really interested in the topic that you're talking about? If not, then don't cite it. Another problem with citations is the biased citations. This is adding or omitting references for any reason other than 5 goals. What might those reasons be? Well, we all know citations have on people's careers, especially in the academic world. So we might cite other people's work as a favor to them. Might be quid pro quo. They cite my papers, I cite their papers, and we're both happy. We should avoid biased citations. Self-cites are cites to your own work. This is not necessarily a problem. In fact, it's almost given that you're going to cite your own work. Self-work is some level of continuation of things you've done in the past. Self-cites are a problem only when they're biased, only when they're spurious. If you're simply adding a whole bunch of citations to your own work just to get your own citation rates up, well, that's a problem, and that can raise red flags with editors. Finally, a problem with citations is when you purposely exclude contrary evidence. Maybe your work contradicts what somebody else has published already. You don't want to deal with that. You don't want to have to be able to explain why you're different. Maybe you don't even know why your results are different. So you exclude those references to contrary evidence. That's a problem. This is a bias in your citations that has to be avoided. You need to include, especially, you need to include citations where the evidence is contrary to your own work. Figures. Figures are a very important part of most papers. A typical paper has between 5 and 15 figures. Why? Because figures are great for quickly transmitting information about large volumes of data. Graphics are instruments for reasoning about quantitative information. They allow you to quickly make comparisons, for example, between data and theory, or between one set of data and a second set of data. It allows you to display trends, make inferences for cause and effect. Often, the figure is the only place in your paper where you document the data. The only place where the actual data is shown is in a figure. So getting the figure right is important. It also needs to integrate with the text in order to tell a story and enhance the overall communication in your paper. The form matters in a figure. Getting a figure to look right, is important for how well it conveys information. I'm not going to go through the details of why the figure on the right does a better job of communicating information compared to the figure on the left. In some of the editorials that I've mentioned that are on my website that discuss various aspects of science writing, one of them discusses why a specific format and finally, because graphs display so much information, so much data and hopefully information, you can use graphs for both good and evil. The question you need to ask yourself, does the display reveal the truth, help to reveal the truth, or does it help to hide the truth? Right? Put your graph on a logarithmic scale. If it makes the information, the truth that the data is telling you come out, you see it more easily. Don't put it on a logarithmic scale if it hides some trend that you don't want to show, or maybe you don't understand and therefore you don't want to discuss. You need to make sure your representations are accurate. And one aspect of that is to carefully document the data. If someone were to quickly glance at your graph, would they get the trend that is the real trend, the true trend, or would they maybe see something, what we call a spurious reading, some quick glance reading of the data that wouldn't be obvious until they looked at it in much more detail? For example, like reversing plus and the minus on your y-axis to make a trend that would go up normally, like it's going down. There's more interesting points to be made here. I won't go into all those details at the moment, but suggest that to do a good job on graphics requires careful work, and you should look at some of the other papers that I've written to get more details. In the interest of time, I'll just move on. One of the last things you write, not the last thing, but the second to the last thing you write when you're working on your paper is the abstract. Leave the abstract to the end. Second to the last, as I've said. What should you put in the abstract? Well, here is what I recommend for exactly how to write an abstract. And this is what I do every single time I write an abstract for every paper that I write. First, I type in these 5 words: background, aim, approach, results, and conclusions, on 5 separate lines. Then, following that word, I write 1 to 2 sentences on that topic. Background. What are the issues that led to the work? What's the environment that makes this work interesting or important? 2, aim. What did you plan to achieve in this work? What are the research questions that you want to answer? What is the gap that you're trying to fill? Don't do more than 1 or 2 sentences on any topic. If it takes 5 sentences to explain it, figure out a way to shorten that, be more succinct. You have to be able to do it in just a couple of sentences. Third, the approach. This is like the method. How did you set about achieving the aims that you just mentioned? Did you use simulation? Did you use experiment? Did you combine theory with some experimental data? What exactly did you do? Finally, results. Not finally, next to last. Results. What are the main results of the study? Go ahead and quote the numbers. If your main result is that the network speed increased by 38%, put that result right there in the abstract so people can see it. Don't be vague. Don't say, we had some improvement in network speed. Well, if you had some improvement, tell me how much. Be specific. And finally, conclusions. How are these results important? Where will they lead? When you're done doing that, then delete these 5 words. Delete background, aim, approach, results, conclusions. Get rid of the line breaks between the sentences, and then clean it up to make it flow like a single paragraph. If you do that, you'll always have a good abstract. You might notice it sort of looks like the IMRAD structure for a paper: introduction, method, results and discussion, conclusions. It's not a coincidence. The structure of the abstract should follow the structure of the paper. After you've written the abstract, the last thing you do is write the title. Now, most of us can't write a paper without a title. So start with a working title. We'd be completely willing to scrap the working title and write a new title when you're done. Title should describe the aim of the work, not the results. Some people like to put the results in their work, make it sound like a newspaper headline. I think that's completely wrong. I think you need to mention the approach and talk about the aim of the work. We have conflicting goals of being as descriptive as possible, but also short in the title. It's hard to do those 2 things at the same time. But remember this, your goal is matchmaking. People are skimming over these titles. You need to make sure that the right reader finds your paper and reads it. And that's the goal of writing a good title. So let me conclude, and then we'll have some time for questions at the end. You don't have to be a good writer to write. This is very good because, let's face facts, most of us are not good writers. Many people learn the science because they're number people, they're hands-on people, they're data people. They're not touchy-feely communications kind of people. Now, some of us are good writers, and hey, if you're a great writer, fantastic. You'll do well. But for the rest of us, we can still write a good paper if we are careful writers. We follow the formula that over time we've learned works really well in communicating scientific information. The goal in writing should be to make your research transparent. You should teach the reader what it is that you learned when you did this research. As a teacher at the University of Texas, I like to think about everything that's important in the world in terms of teaching. I have anything to say, it has to be because the person listening to me, the person reading my paper, wants to know what I already know. That is teaching. How can you make your paper a good vehicle teaching information? And finally, I'll mention that to write a paper and get it published is more than just being about you. It's not about your career. Of course, it is about your career, at least to a point. It's not just about enhancing your prestige or your place in the community. Those are important goals. The purpose of publishing a paper is to join the community of science, a part of the scientific enterprise, to further the goals of scientific progress. And you can do that by getting your work published. And that's why it's valuable to do a good job, a careful job, of thinking about all these aspects that I've just talked about and how to write a paper so that you do the best job possible to communicating that hard work that you've already finished to others. And after all, that's what it means to be a scientist. Thank you so much for listening. I've had a great time talking to you, and now I'll open it up to any questions that might be here. Let me look through and see what we have.
Thank you so much, Chris, for speaking with us today. And everyone, please go ahead, and if you have questions, please go ahead and write them in the chat box, and Chris will read them off for us.
Yes, so far no questions, but please type them in if you have them.
Looks like we have one coming in from Chris at the U of A.
It hasn't popped up yet on my chat box. By the way, here's a picture of a recent cover of the journal I'm the editor-in-chief of. I've been the editor-in-chief there for 3 years. It's published by SPIE, the International Optical Engineering Society. All right, here's the question. How much of getting a paper accepted depends on the reviewers? I got a paper rejected recently and noticed a very different response from the two reviewers. One was much more harsh than the other. I wonder if it would have been gotten accepted if I had two different reviewers. Well, that's a very good point. First of all, let me say that when you say harsh, I hope it means they were harsh about the work and not about you. I think I've reviewed a lot of papers. It's always important for reviewers to have a constructive and considerate tone when writing their reviews and not be mean. Mean reviewers are just the worst. If you've ever had a mean reviewer, please don't let it hurt your feelings. I know I have had my feelings hurt by having a mean reviewer. You know, I don't know. You never know who they were. Having a bad day. They just enjoy flouting their power or whatever. What's important is not the people. What's important is the science. So try to divorce the personal aspects of it. But if the harsh review was criticisms of the work, as much as that's not always fun to hear, it's very valuable to hear that kind of criticism. All right, now back to your question. I wonder if I would have gotten accepted if I had two different reviewers. Let me say two things to answer that. One is, reviewers do not decide whether a paper gets accepted. Editors decide if it's accepted or rejected. Reviewers make recommendations, but quite frankly, the recommendations of a reviewer are not that important. Not important to the editors in general. What the editor looks for is the substance of the review. If a reviewer says, this is a terrible paper, it should be rejected, and then that's the end of the review, that review is completely worthless, and a good editor will simply ignore it. If, however, there's a long list of substantive criticisms of the work, and the editor then has to make a choice. And the choice is this: how easy will it be for the authors to make the corrections to bring it up to the standards that you're trying to achieve with your journal? If it's too much, if you're too far away from that goal, then you might get rejected. I get rejected if it's out of scope, as I said, not anything new, etc. So a good editor uses the substance of the review to make their own decision about whether a paper should be accepted or rejected. Now, that said, there is a certain luck of the draw when it comes to reviewers. It would be great if we could have 10 reviewers and get a nice spectrum of attitudes about the topic or expertise about specific areas that they might be able to comment on. It's just not practical. Most journals can only afford to get 2 reviews simply because there's limited number of reviewers who are willing to put forth the time and effort to review a paper. A good review takes 3 to 8 hours to do. That's a lot of time off of what you hope is someone who's very knowledgeable in that field. So we only get 2 reviewers, and yeah, the luck of the draw might be a little different, but that's just kind of the way it goes. Even if you're rejected, though, you should take the criticisms to heart, fix everything that you can to make your paper better, and then you might think about resubmitting it to that same journal. If you're thinking about that, give a call or send an email to the editor-in-chief first to see if they think that's a good idea, or go to a different journal. You're fixed in revised paper, and hopefully that will result in a paper that can be accepted for publication. Oh, thank you. Thanks is my answer from Chris. Thank you. Any other questions? We're waiting, and if anyone wants to type in anything, I'll mention that the picture of me you see on this final page was taken in New Zealand, which is my favorite place on the planet. All right, here's a question from Eduardo. Hi, thank you for the talk. Once rejected, may I take the comments, change my paper, and submit to another publisher? Absolutely. That is, in fact, what you should do. It is possible to submit back to the same journal, as I just mentioned a moment ago, but that would require a discussion with the editor-in-chief first, to make sure that they think that that is a good idea. Nonetheless, if you don't want to do that, which is perfectly fine not wanting to do that, you can find a different journal to submit it to. Please change the paper, make it best you possibly can, answering all those criticisms. And your chances of being accepted at the next journal will jump dramatically if you've had good reviews with good substantive criticisms. When you submit to another publisher, you have a choice. You can mention in the cover letter, in the communication directly to the editor-in-chief, that you did submit it somewhere else and it was rejected, and you took the reviewer's criticism in mind and then submitted it here. You don't have to do that. That's completely voluntary. Here's what sometimes happens. You're working in a very specific field. There's a few people that are considered key people in that field, experts. They get tapped to review papers frequently. It is possible that you will get the same reviewer for your paper at a different journal that you submitted to. It's happened to me as a reviewer. I review a paper, it ends up getting rejected. 2 months later, I get the paper submitted again to a different journal, and that other journal asked me to review it. Somewhat of a coincidence, but sometimes not really a coincidence, because I'm the right person to review that specific paper. Let me tell you, for me, the first thing I look for is, did they respond to all those criticisms that I gave them the last time? Did they make the changes to fix their paper? If you submit it without fixing these errors and you go back to the same reviewer, you're just setting yourself up for another rejection. Any other questions? Feel free to type them in. Thank you, Eduardo. Oh, Chris is typing in another one. I think most of us are faster talkers than we are typers, but don't worry about typos and stuff. I'm sure I'll be able to figure it out. Just type and submit it. While we're waiting, I'll just mention that the background you might see in this video, I don't know how clear it is, this is my home office. Out of my home most of the time, and it's a very pleasant experience if you've never done it. Sorry, no mic, of course. So, how do you differentiate between how much of your work will go into a preceding article so that you can publish your work in a peer-reviewed article? I've heard that things like self-plagiarism can get you into trouble. All right, this is an interesting topic, and it's a topic that has more than one viewpoint, and it has a couple of aspects to it. I don't know how much I'll be able to do justice to this broader topic, but I'll try. First, in my opinion, the phrase self-plagiarism is an oxymoron. Stealing someone's words means stealing from someone else. You cannot steal from yourself. Taking money out of your right pocket and stick it in your left pocket is not a crime. There is no such thing as self-plagiarism. I reject the term out of hand. However, there is something called a copyright. When you publish work, that work often becomes copyrighted by the publisher. You sign over the copyright to that publisher. That publisher may not want you to reuse those same words. What's being copyrighted is the words, the presentation. The data is not copyrighted. You can use the same data again. The presentation is copyrighted, the figures and the words. If you want to use those figures and words again, then you need permission from the copyright holder. So that can get you into trouble if you reuse that information in a way that the holder of the copyright does not want. Now, sometimes a conference is run by the same organization that publishes the paper. For example, SPIE publishes the journal I'm the editor-in-chief of. They also hold many, many conferences. Because of that, there are no copyright problems, and SPIE has a policy that it is absolutely okay to take work that has been published in one of their journals and publish it as published as a conference proceedings and publish it in a journal. You have to acknowledge that fact. You cannot try to hide that fact, and that's the next most important thing. Never hide the fact that this work might have been presented at a conference and published in some form in the past. You must be completely open and upfront about that to the journal when you're submitting. Now, that said, the next hurdle, besides the copyright hurdle, is the novelty hurdle. Journals want to publish something new. If what you've done has already been published somewhere else, many journals will reject it simply because it's not new. And that becomes maybe the bigger hurdle that you have to get over. If it's gone into a conference proceedings, it's available online on the web, you submit it to Science, you submit it to a lot of journals, they may say, nope, it's not new, it's been published before, therefore. The answer to that depends upon the journal that you're submitting to. So you need to look at that journal and what their policies are. Here's, though, a rule of thumb that might be useful. When you're presenting information at a conference, it's often preliminary. It's often a piece of what the final work will be. Then you clean it up, you add more, you develop your theory, maybe more data gets collected. You do more detailed analysis, not just the preliminary analysis you did at the conference. Now you've got a journal paper. And this work is actually significantly different than what was published at the conference. If it's more than 50% new, this is my rule of thumb. If the paper has more than 50% new stuff compared to what had been published before, then I think you passed the hurdle of saying there's novel aspects to the work. All right, here's Chris's follow-on. Specifically, I have published proceedings articles in Photonics West and hope to publish an article with the same results, but with extended work in your journal, actually. Oh, that's fabulous. Well, let me tell you very specifically, SPIE has a written policy about proceedings to journal. And go on the website and look it up. You can say SPIE proceedings journal publication policy or something like that. You'll find it. The policy is very simple. You are allowed to take a proceedings paper and submit it to a journal. Chances are you've changed it. Chances are you've improved it. Often proceedings papers are not good enough to be submitted to a journal as they stand. But in SPIE proceedings, you're allowed to take that paper and submit it to a journal without any problems. No complaints. You simply have to tell us what proceedings paper this new paper is based on and tell us what, if anything, has changed. You will not get in trouble. It happens all the time. I do it myself. In fact, last week, I submitted a paper to an SPIE journal based on an SPIE conference proceedings, and the fact that I did that will not cause any problem. I simply acknowledged that in the submission process. I told them exactly which paper, proceedings paper, that the new paper was based on. It's got a few things new. Maybe 10% of it is new, a better analysis, a couple of extra data points, but basically a similar thing. And for SPIE, that's perfectly fine. Any other questions? I know we've hit 3:01. We're at the end, and if we have a last-minute question, I might be able to squeeze it in at the end before we have to cut out. We might have somebody writing a question here at the last minute. We'll pause for just a second to see if that's the case. While we're waiting, I'll put up these two graphs, the good one and the bad one. And you might recognize the bad one on the left. That's the Excel default. The Excel defaults for XY plot are terrible. You have to change them. Turn it into a good-looking graph before you submit it for publication. The one on the left looks like an amateur. The one on the right looks like a professional scientist. Put up that graph. No questions?
All right, well, I guess we'll go ahead and say a big thank you for speaking with us today. I have heard some great questions there and answers. Thank you all.
And thank you. Thank you, Amy, for hosting this and all of you for attending. Check out the website, which is on the very first slide, or also right here. And it's got lots of, as I said, papers on each of these topics if you want more details. Thank you very much.